Okay, this is kind of the last piece to the puzzle. Yeah, so instead of asking, does the series converge or diverge, now I'm asking you to find the interval of convergence. And so we used to just have n's, and now we're going to have n's and x's. And so what I mean by that is, let's look at this particular series. Let's look at the series from 1 to infinity of x plus 3 to the n all over n. Okay, this is not a geometric series. This n makes it non-geometric, and there's some x value. And so I can't ask the question, converge or diverge. Now I need to ask, what x values make this thing converge or diverge? And again, anytime you're going to look for the interval of convergence, you are going to do the ratio test. There is not an example in Calc BC in which you're asked this question and you're not going to do the ratio test. So let's come down here and let's do the ratio test. The ratio test says we want to look at the limit of a to the n plus 1 over a to the n as n goes to infinity. Okay, L'Hopital says that as n goes to infinity, n plus 1 and n are the same, and this has one extra factor of x plus 3. This is x plus 3 to the n plus 1. This is x plus 3 to the n. This has one more x plus 3. Okay? And what does the ratio test say? The ratio test says that we want our limit in between negative 1 and 1. Now, when we first learned the ratio test, we said that we wanted our limit in between, or less than 1. But now the fact that we're allowed to have our series alternate, because now we know the alternating series test, now we can have it between negative 1 and 1. And we can subtract 3 from everything and get this. And we're getting close. So what we've said is the ratio test says that as long as x is between negative 4 and negative 2, this series will produce a limit that's between negative 1 and 1, so it's going to converge. But now I need to look at the endpoints. And so, all right, I'm not sure what happens if x is actually equal to negative 4 and equal to negative 2. So let's go ahead and go up here. So let's say if x is exactly negative 2, what happens to the series? Well, it just produces a particular series. If x is negative 2, this is negative 2 plus 3 is 1. 1 to the n is just 1, and so the series is just 1 over n. But that diverges. That diverges based on the p-series test. So that tells us to not include that endpoint. Well, what happens if x is equal to negative 4? Well, that produces the same series, except negative 4 plus 3 is negative 1, so it's negative 1 to the n, 1 over n. And that's the alternating series, 1 over n, and that actually converges. And so we want to include negative 4 is part of the interval of convergence, and so we make that adjustment, and now we can circle that as our answer. Again, if you think about what this did, the exponential still controls everything, and this plus 3 did what it always did. It just shifted our interval down. So instead of being centered at 0 and going from negative 1 to 1, now we're centered at negative 3, and we go up to negative 2 and down to negative 4. And this n kind of controlled the endpoints. Hopefully you're going to start to get an idea of what things control what. So let's look at another one. How about the series from 1 to infinity of, I don't know, 4n. Oh shoot, not n. Silly. 4x to the n over maybe n squared. Okay, let's do the ratio test. The limit of 4x to the n plus 1 over n plus 1 squared all over 4x to the n squared, n goes to infinity. L'Hopital says that n squared and n plus 1 squared as n goes to infinity are the same, and we know our exponentials. This is 4x times 4x to the n. This is just one extra factor of 4x, which means I'm going to take that limit and set it in between negative 1 and 1, and then I'm going to divide by 4, and I get this. Now I need to look at the endpoints again. Okay, so if x is exactly 1/4, 4 times 1/4 is 1, 1 to the n is 1, and I get the series 1 over n squared. Well, 1 over n squared converges. So we want to include this endpoint. Okay? That endpoint is part of the converging interval. Anything in between there, of course, converges on the ratio test. And now what happens if x is equal to negative 1/4? Well, hopefully you can guess that a negative 1/4 just makes this alternate, so it adds a negative 1 to the n, 1 over n squared. But this alternating series, well, it also converges. Okay, so both of them converge. And so then the interval is including both endpoints. And you're going to have some times when one of the endpoints works and the other one doesn't. In this case, both endpoints work. It just depends. See, this n squared affects the endpoints, just like this n affected the endpoints. The plus 3 was a horizontal shift, just like it always is with functions, and it moved it left 3. And then this 4 was some stretch. But stretching this actually shrinks this interval. Right? You're multiplying your input by 4 and then raising it to a power. And we know we can't have this bigger than 1 or else this exponential is going to grow. So multiplying this by 4 actually shrinks what x can be. Because if x is bigger than 1/4, then 4 times x is bigger than 1. And then something bigger than 1 to the n will make it diverge. And so that 4 is a very predictable thing in terms of how it affects everything. And again, we can do all sorts of things. We can do, how about x minus 1 to the n over the square root of n times 2 to the n. Something like that. And hopefully you're like, all right, let's think about this. That's going to divide it by 2, so it's going to do the opposite of multiplying by 4. So this is going to make it the interval twice as big, and that's going to move it to the right 1, and that square root of n is going to mess around with the endpoints. And the square root of n is similar to n, in which the alternating version will make it converge, and the non-alternating version won't make it converge, and we'll have to figure out which endpoint that actually is. Okay, so let's do the work here. The ratio test is where you start. So we want to look at the limit of x minus 1 to the n plus 1 over square root of n plus 1 times 2 to the n plus 1 all over x minus 1 to the n over square root of n 2 to the n. Look at the limit as n goes to infinity. Okay, the square root of n plus 1 and the square root of n as n goes to infinity, that ratio is 1. And then this is one extra factor of n plus 1. And this is one extra factor of 2. And hopefully you did enough ratio tests before that you can see those without doing too much work. I then want to set that in between negative 1 and 1, multiply by 2, add 1, and hopefully you can see that the interval now goes up 2 and down 2, and it's centered at 1. This is exactly what we predicted. This minus 1 moved our interval of convergence center, right? Usually it's centered at 0. We moved it to 1, and this stretched it up 2 and then down 2. And now we have to check the endpoints. So if x equals 3, I get 3 minus 1 is 2. 2 to the n over 2 to the n is just 1. So then I get the series 1 over square root of n. If x is negative 1, I get negative 1 minus 1, which is negative 2. Negative 2 to the n over 2 to the n is just negative 1 to the n. So I get the alternating. So in this case, again, this diverges, this converges, and so I want to include that endpoint but not that endpoint, and then I box it up. Okay. All right, I think I need to do some more examples, and getting close. All right, so those three were kind of the basics. Let's throw some loops at you. What if I did one like this? N equals 1 to infinity of 5x to the n over n factorial. And this one I hopefully is pretty easy when you think about it in the end. So we do the ratio test. Let's look at the limit of 5x to to the n plus 1 over n plus 1 factorial all over 5x to the n over n factorial. Look at the limit as n goes to infinity. Okay. 5x to the n plus 1 versus 5x to the n. Those are going to cancel and leave you just with a 5x. And then hopefully you've done enough ratio tests to know that n plus 1 factorial and n factorial, this has one extra factor of n plus 1, so it gets an n plus 1. Now again, apply the limit. What is the limit of this as n goes to infinity? Well, that's 0. You're like, wait a second. That means the limit is always 0. No matter what x is some finite number. If you let n go to infinity, you get 0. Well, what does that mean? Well, that means x can be whatever it wants to be because the limit is always 0. So our interval of convergence is everything. And you're like, why? How could that possibly happen? Think about it. Who controls? The exponential or the factorial? And you're like, well, we all know that the factorial dominates, and that's what this says here. You can make the exponential as big as you want. The factorial will always dominate the expression and make it converge. So you clearly can have an infinite interval. And again, it's pretty easy to create one. Just put a factorial in the denominator and put whatever you want in the numerator then, and nothing's going to matter. And again, hopefully you can see that I can flip that. If the factorial was in the numerator, then it would be infinitely big no matter what, and then there'd be no interval of convergence. No x value, might work. Okay, let's do one more. We'll flip this around. And how about we do 4 minus x to the n over n, something like that. Okay, so let's look at the limit of 4 minus x to the n plus 1 over n plus 1 all over. Again, I'm doing the ratio test every time. Over n as n goes to infinity. L'Hopital says that this and this cancel, and this has one extra factor of 4 minus x. Okay, so the ratio test, we always want that limit to be between -1 and 1. So let's write that. And then let's solve here. I'm going to subtract 4 from everything and get -5 and -3. And then I'm going to divide by -1 or multiply by -1. And then I need to flip all the inequality signs. And I get that interval. Okay, now let's check those intervals. If x equals 3, what happens? Well, if you let x equals to 3, you get 4 minus 3 and you get 1, and you get 1 to the n, which is just 1, and that produces the series 1 over n. 1 over n diverges. So don't include that endpoint. If x equals 5, 4 minus 5 is -1, -1 to the n. So I get the alternating version, -1 to the n of 1 over n, and we know that converges. So we want to include that. And most of the time you're going to rewrite it. So this is just kind of written backwards. We'd say 3 less than x. And hopefully you can see that now it's the top one worked and not the bottom one. See how the top one here, the 5, the greater one, actually made it alternate because this -x kind of flips everything, and the bottom interval didn't. And again, I showed you examples of an infinite integral. I showed you examples where the bottom one worked, where they both worked, where the top one worked. And you can look at just a nice geometric case. And again, a geometric case is something like, x plus 2 over 3 to the n from 0 to infinity. And this is geometric. Okay, this doesn't even need the ratio test. We know that neither endpoint is ever going to work, ever, in something that is purely geometric. Again, you can see that it doesn't have like an n factorial. It doesn't have any of those terms. It's just a r to the n. And there, when you do this guy, you can show that no matter what, we don't even have to check the endpoints. We know that this is the answer because for geometric and geometric only, it's always strictly between -1 and 1 is your r value. And again, if you wanted to check it, you can plug in 1. You get 1 plus 2 is 3, 3 over 3 is 3, 1 to the n is 1. So summing up an infinite number of 1s is infinitely big, which is why 1 doesn't work. And the same thing for -5, it's just negative. Okay, so hopefully this gets you started on the interval of convergence. I guess I want to make one more point about, this is a silly one, the radius The radius of convergence. Again, the radius, think of everything as a circle. And here's the center, and the radius is this distance. So if you look at this one, where's our center? Our center is at -2, and we go 3 up and 3 down. So this has a radius of 3. Again, fairly predictable by that 3. What does this have a radius of? Well, this center is at 4, and it goes up 1 and down 1, right? This has a radius of 1, right? It's just half the total width. We can go back to any of these things. What does this have? This has a radius of 3. It's centered at -1, and it goes, oh, excuse me, it's centered at -3, and it goes up to -2 and down. This has a radius of 1. This has a radius of 1/4. This has a radius of 2, right? It centers 1, it goes up to 3, and down to -1. So they will ask you for the radius of convergence, but again, if you've already found the interval of convergence, finding the radius is really easy. It's just half the total width. Just think of the total thing as being the diameter, and you want the radius, which is half. Okay, hopefully this gets you kind of started on your interval of convergence.